Hi everyone, this is Mrs. GA, and today we're going to learn how to graph cubic functions. First, we're going to start by looking at the parent function for our cubic functions, which is just x cubed. So we'll start by making a quick little t-chart to see what points we're given. So if we have -2 cubed, that gives us -8. This -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So if we plot those points, looks like this. So we have a graph that kind of makes this curved shape. So as it approaches the origin, that point 0, 0, it kind of flattens out a little bit like this, and then it continues on through. And you get kind of this S-shaped curve. So that's the general shape of our cubic functions. Now, of course, this can change if we have transformations, which we'll work with today. But again, this is what the parent function looks like. So some key characteristics: our domain and range are both all real numbers. Our end behavior for the parent function, as x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity, f of x approaches negative infinity. We have what's called a triple root at x equals 0. Because we have that x cubed, it's like having the 0 of 0 3 times, so we call that a triple root. And what this does to our graph, which we'll learn about in the next section, is actually kind of flattens out our graph, but it continues on through. So that's what's kind of causing that curve in our graph. And cubic functions are, or the parent function is an odd function because f of negative x equals negative f of x. All right, so now we're going to graph some transformed cubic functions. And here we're going to fill out a little t-chart to help us find some new coordinates for our graph. So we're going to look at our new equation, and we're going to first decide what transformations do we see and how will it affect our x and y coordinates. And then here you can see I have 3, I call these like our key points from our parent function. So we can transform these 3 points, and it will give us a fairly accurate graph for our new function. So a few things I see going on here. I see, let's start with the vertical transformations. I see we have a vertical reflection over the x-axis, a vertical stretch by a factor of 2, and a vertical shift down 1. So all of these will affect the y value of our graph. So to do that, we would multiply our y values by -2 and then subtract 1. Now let's look at our horizontal transformations. This is actually going to shift our graph to the right 1. So if we want to shift our coordinates to the right, we're actually going to add 1 to all of our x values. So if you apply these changes to your x and y values, you will have 3 coordinates for this new function. Okay, so again, we're going to take all of our x values and we're going to add 1. So it gives us 0, 1, and 2. And then we're going to take all of our y values and we're going to multiply by -2. So -2 times -1 is 2, minus 1 is 1. -2 times 0 is 0, minus 1 is -1. And -2 times 1 is -2, minus 1 is -3. So these are 3 coordinates from f of x. So now all we need to do is plot our coordinates. So we have 0, 1, 1, -1, and 2, -3. And then when we draw our line, we should know that it's going to kind of flatten out again at that center point and then continue through. So we still have that kind of S-shaped graph, but this time you can see instead of being an increasing graph, it's decreasing due to that reflection. And you can see our center point, which used to be at the origin, has shifted to the right 1, down 1, and it is stretched out vertically. So we're always going to go kind of based off where that center point is. That 0, 0 is going to be like, we'll call that the center of our graph. It's kind of like shifting the vertex of an absolute value function. All right, let's try another one. So here in this function, you'll notice that we have a horizontal shrink. So remember, when you have something like this, we do need to make sure this is factored out before we evaluate what's going on. So I do need to write it like this. So 2 times x plus 3 all cubed plus 4. So there's, two different ways we could go about this. We could actually cube the 2 and then put it out front. That is totally fine. Or we can keep it inside and treat it as a horizontal shrink by a factor of 1/2, which is, let's try that for this problem. So again, remember any b value here, the stretch or shrink factor is the reciprocal. So the reciprocal is 1/2. So this is actually a horizontal shrink by a factor of 1/2. So I'd multiply my x values by 1/2. And then this shifts our x values to the left 3. So to do that to our coordinates, we're going to subtract 3. And then the only vertical change I see is the shift up 4. So we're going to add 4 to all of our y values. So let's take a moment and fill out our t-chart. So you should get these 3 coordinates, which we will graph on the right. And for something like -7/2, we just need to kind of estimate where that would be. So for -7/2, it definitely needs to be between 3 and 4. So 3.5 is about here, and then 3. So we have our coordinate here. And then we have -3, 4. And then we have -5/2, 5. So it looks like this. And do your best. This one's a little bit harder to do because it is kind of small, but we want to try to show that curve in our graph right here, that it kind of flattens out but keeps going. All right, so at this point, I'm going to ask you to pause the video and give this one a try on your own. Please write the rule for the transformations for your t-chart here, and then find your new coordinates. And we'll check your answers in just a few moments. All right, go ahead and check your work here. I think the tricky part of this one is remembering that if you have a horizontal reflection, you also need to make sure it's factored out before you evaluate what's going on. So this is a vertical shrink by 1/2 and a vertical shift up 3. So that's how it will affect our y values. Sorry, this should say y. And for the horizontal changes, this is a horizontal reflection, and this is going to shift our graph to the left too. So make sure you factor out that negative before you assess what's going on. So you multiply your y values by -1, and then you subtract 2, giving you these new x values. So these are your new coordinates. So your graph looks like this. So for these graphs, because it is an odd function because the parent function is odd, horizontal and vertical reflections essentially look the same. They do the same thing to your graph. So again, this looks like it could be a vertical reflection because you can always cube a negative and put it out front. So vertical reflections and horizontal reflections achieve the same thing graphically for these types of functions. All right, so now we're going to look at a graph and see if we can create an equation for the function. So for this, we'll use a standard form to help us. We're going to do f of x equals a times x minus h cubed plus k. And when we find our horizontal and vertical shifts, we'll kind of go from that center point of our graph that we know is usually at the origin for our parent function. So if I compare the origin to here, I can see that my graph was shifted to the left 1 and down 1. So we can start by saying a times x plus 1 cubed minus 1. Remember, to shift to the left 1, we have to do the opposite for x. But now we still need to find this a value. So to do that, we can substitute one of the other points we know to find it. So you can substitute either point. I'll substitute 0, -4. So I'll add 1 to both sides. Here, 1 cubed is just 1, so our a value is -3. And then this we just need to substitute back in here for our final answer. So it's -3 times x plus 1 cubed minus 1. And we can leave our answer like this. Sometimes I might ask you to actually multiply it out, but for now we can leave it like this. All right, go ahead and pause the video and give this last one a try, and we'll check your answers in just a few moments. All right, go ahead and check your work here. Be careful when you're finding that a value, like in this step. 2 minus 4 is negative 2, and negative 2 cubed is negative 8. So be careful with that negative. Our a value ends up being positive 1/2, so we get this as our function. Okay, that is all for today's lesson. Thank you so much for watching.